What's up, everyone? Ali and Mark here from Tower's Edge. We are actually doing our, I don't know, episode third, fourth, something like that. And we want to talk about something around antennas. Antennas are important when you're trying to deploy Wi-Fi, depending on what you're trying to do. There are a lot of scenarios where sometimes you need to deploy external antennas, whether it's a directional antenna or an external omnidirectional antennas. They play a crucial role when you're trying to provide coverage. And we are here today with a brand new company that I met them for the first time and found out about them at the WLPC in 2024. And then I emailed them and kind of was curious about their technology. They've made some good, recent news and headlines around what they're doing. So we're gonna see what they got going on.
All right, hi Mohammed
we're
and
excited.
Mark. Thank you for having us.
Welcome.
So I'll let you. I mean, like, yeah, I know you. I have spoken before multiple times. Yeah, I'll let you guys introduce yourselves, and then we'll talk about your company and what you're doing.
Octavio, you go first.
Well, my name is Octavio. I am the field application specialist. So my job over here is trying to get the most weird scenarios that I can get, or the weirdest ideas that people come to us and ask to test. So what we're trying to do is we try to verify that we can extend the range using our device, or if we can bend. Well, we have received this term in the last week that we had this session, bending the Wi-Fi. It's something like the R-bender, but with Wi-Fi. So I don't know if it's clear enough. So I am in charge to test all the crazy ideas that my boss over here had, or that she sees on TV, something like that.
Yeah, instead of the last airbender, we're the last Wi-Fi bender.
I was just thinking that. Yeah, it's so it's you're doing some air bending right there. That's interesting.
Yeah.
To clarify,
RF
you're
bending.
looking to bend around like objects and things into crevices that you're not getting signal in previously, right?
Exactly. Not to hurt people in any way. Yeah.
So
For
there's
now.
there's air bending, and there was a movie around bending the bullet too. I don't know. I think it was with
yeah.
Angelina Jolie,
right,
and
yeah.
I forgot the name of the guy, and they were like, bending the bullet or something like that around a little bit, or that was interesting too. So talking about bending, right? You're bending airwaves and helping improve the coverage, basically high level, and extending the coverage as well.
Yeah. So not just bending it, but just controlling it in general, controlling the power, controlling the face, so the angles, being able to basically put the connectivity where it's needed, instead of kind of just spraying it everywhere.
Okay.
Maybe I should do the intro.
Yeah, sorry. Yeah, go for it.
So I'm Artmiz, and I'm the founder of the company. We started in 2021. I can't really say we were in stealth mode at the beginning, but we weren't really being as public with everything as we're being now. Mohammed, like you said, we started with we met in at WLPC, but that was Octavio and I's first WLPC. But that was an introduction into the Wi-Fi community that we definitely needed, but didn't have before that. That was a lot of fun.
Yeah, that conference is, of course. I mean, it's the, I don't know, Mark. What did you call it? Nerd vacation or something like that?
Nerd vacation.
Nerd spring break or something like that. Mark used the term.
Nerd spring break.
Nerd spring
Drew calls
break.
it.
That's what you called it. Yeah,
that's what Drew calls it.
Yeah, so it's definitely great. I mean, you get to know. I mean, that's how I found out about you, right, for the first time, because I saw you guys talking, and I'm like, well, who is this? What is this company? I mean, never heard of them, and I obviously some Google foo and kind of obviously then started reading about it. So it was very interesting, and that's when I kind of emailed you after that.
So did you come across our website by any chance?
Yeah. I mean, yeah.
Was that at all helpful?
I mean, there was not much over there, but then I found an
okay.
article. And so it was just basically Google, right, doing research on the company, and I saw your website. There was not much there. I'm like, okay, what's going on right there? Then I ran into an article, and I read the article. I'm like, whoa, that's pretty cool, right? So that's how I kind of like found out about it. Now you mentioned, so one of the things I want to mention, right? You're bending airwaves. You're extending the coverage. It's a passive technology. I mean, this is not an AP or a repeater, right? Just to clarify.
Exactly. It is passive in the sense that there's no processing of the signal happening, but it is active in the sense that you have to provide power to it. So it's passive from a signal processing perspective.
Okay, so it does require power.
It does require power.
So
Very
it's not,
small amount of power, but it does
But is that
it,
power coming from? Is it a
0.7 watts.
Yeah.
Sorry.
7
Sorry.
watts. What?
4.7,
0.7?
yeah.
4.7.
Yeah, in fact,
4.7.
at this moment, we are using for the demos that we are running outside of the office, very common power bank, and well, it can provide hours of power. So the other thing that is important to mention that with the demo kits, we are including a PoE converter to USB-C, but the thing is that with any kind, well, I mean, with something that can provide the 4.7 watts, the unit will work.
Okay, gotcha. So
So standard
basically, I
PoE.
mean, we can't use Ethernet basically. I mean, you need some kind of converter. I mean, I can't take an Ethernet cable plug directly into your unit, for example.
I mean, on the box itself, we don't have anywhere for you to plug an Ethernet port. Like there's no Ethernet port. And the reason
Okay.
for that is because we wanted to make a point to say that you don't connect the device into the network in any way. It's all happening over the air. So the connection to the Wi-Fi is happening over the air. You don't even really need to assign an SSID to it. It doesn't have an IP address. It's not a node in the network in any sense. So that's why we don't have a we don't have a Ethernet port on the box. The USB-C is just there to provide power, so there's no data. It's not a data cable. But the PoE converter that Octavio was just talking about is just like if you don't have anywhere to, if you don't have a DC plug anywhere or even an AC plug to like plug your USB-C into, then we do have that little dongle that you can plug into our box USB-C, and then it provides Ethernet on the other side, so you can just plug it just for power.
Okay.
Oh, awesome.
That's pretty cool.
Are these units meant to be mounted on the ceiling, on like a table? What are you guys kind of planning
That's a really
for
good
mounting
question. It
options?
really depends on the use case you have for it. So you can hang them. Octavio, I think there's a bunch of noise around you. Did you want to? Yeah, maybe you could move. I don't know. So there's we can mount them in a lot of different ways. What we've done is that we've actually put mount holes all around the box, so that you can mount them in whatever orientation that works for your use case. But an easy way to think about them, if you have a lot of ceiling mounted APs, is to mount them kind of like an exit sign hanging off right next to the AP. And so that's because you want the boxes to our devices, and I'm gonna keep calling them boxes. It's a LATYS focus. That's the name of their product. But you want our units to be within a short distance to the origin of the signal, so to the AP. So you want to be between 0.5 meter to 6 meters at max from the AP. So if your AP is ceiling mounted, then you want the device to be close to that AP on the ceiling, then you can hang it off like an exit sign. But if your AP, for whatever reason, is sitting on a desk, then you can put it on a desk and it can just stand on its own.
Oh, awesome. Okay. So 0.5 meter to 1 meter away. So you want them super close, which makes sense if anybody's ever done home mesh on Wi-Fi. You want to get it closer to the radio. Everybody tends to put it on the edge where it's not working, but the concept is you want to be a little bit closer, so it just extends the signal, so at least has a good signal. So that makes sense that you're wanting it closer to the unit, so the signal gets broadcast at a higher, so the receive of the device is strong enough that it can relay it. So that makes sense.
Absolutely. That's it.
Cool.
And you can put it at either end of the link. So if your user end device, yeah, there you go. There's the box and all the
Okay.
different manholes that Octavio is showing right there.
Awesome.
But so you can put it on either end of the link. So on the AP side, you can put it, or if your user is somewhat stationary or in an area that's kind of defined, they don't roam around everywhere in the building, then you can put it at either end. But if you have a mobile user, a moving user, then it's probably easier just to place the unit closer to the AP and just kind of leave it there.
Awesome.
So they're directional, or they're like their
Yes.
signal. Okay.
Yeah, very good point. Octavio just held it up. There was an arrow on the side of the box. Octavio, do you want to hold it back up again? There you go.
Okay.
So that arrow is showing the direction that the signal can travel through. So if you need to boost both your uplink and downlink, then you're going to need 2 units. And you just do that. You just flip it.
Okay. And then like what's the beam width? Is it like 90 degrees, 60 degrees, or can it be customized?
It's 60 degrees.
60? Okay.
It can be customized, but it actually means a lot of different things that
Sure.
we've decided to not do at the moment. The version that Octavio held up, that version is about a 60-degree input and 60-degree output, and 60 degrees like 3D, right?
Sure.
So
So
elevation and azimuth.
okay, so you mentioned 2 units, right? So I guess so I'm thinking like a very simple use case scenario, right? So think hallways, right? So if it's a hallway and it's like a 90-degree, and then there's an AP in one hallway, but the second hallway does not have it, and I just need coverage. Instead of putting an AP, I can technically put 2 of these units, one actually for uplink and one for downlink, and that can give me coverage pretty much in the second hallway without putting an AP in there.
Absolutely.
Now the follow-up question would that be, some people will discuss and the question will come up, well, what about like the asymmetrical connectivity from the clients to the access point, right? Where client radio obviously is not as powerful as an AP. Now you're extending the signal that far, and there may be a lot of retries, for example, which I've seen sometimes, right? When people use an omnidirectional AP and they blast the power to like 20, 23 dBm on them, right? Clients will connect, associate, and all that, but there's a lot of retries depending on how far that client is. So in this case, how is this is taking care of that situation like that?
Well, in fact, we have performed some tests for that kind of a scenario where we locate a IoT device at the end of the link. The only difference that this IoT device have is that it operates on the 5 gigahertz range, because most of the IoT devices are operating in 2.4 at this moment, but we were able to get this device. So the thing that we were trying to test is this concept that you just mentioned. So the thing that the IoT device was doing is it was connecting to the access point, and it was sending 50 HTTP requests just to verify that we are pushing data over here. And well, using nothing in the middle as baseline for this testing, we have observed something like 40% of packet retries in a distance of around 30 meters or 90 feet. But when we put the device in a distance of around 3 meters away from this IoT device, and we pointed to the access point, we come from 40% of packet retries to something below 2% of packet retries.
Wow.
And in that case, we are using it just to improve the uplink. Because, just like Artmiz mentioned, if you want to get something like a symmetrical improvement, you need 2 of these surfaces. But the real scenario most of the times is that the connection is asymmetrical, just for the reason that you mentioned, that the devices are not as powerful as the access point.
So that leads me to another question. So you just mentioned you wanted a half a meter to a meter from the AP side, right? What about the client side? Does it need to be close to the clients? If you're doing the symmetrical or one on both sides, you want the one close to the AP on this side. How do you handle the client side? Does it need to be as close, or can you have it kind of a little bit further distance on the client side?
In fact, on the client side, it works in a distance from 50 centimeters to 6 meters, and you need to consider that the coverage radio is the same 60-degree cone. So you need to be 50 centimeters away from the device because you don't want to work in the near field. So
Okay.
after the
Okay.
50 centimeters, you can see it, you can see the game, and well, it will cover the 60-degree cone in also in that direction.
Okay.
But
Okay.
basically, the recommendation is the same distance on either side of the link, the
Yeah.
0.5 meter to 6 meters on either side. You just don't really want to be right in the middle of the link. That's the worst place to have the focuses.
So this is really use case for devices that don't move so much.
Actually, you could put both the uplink and the downlink box close to the AP and allow your users to move anywhere inside that 60-degree cone.
Oh, okay.
Mm.
Okay.
So
There's
yeah,
nothing keeping us from putting both boxes together on one side of the link. Sorry, go
Okay.
ahead.
So I was gonna say, so does each box have basically 2 sets of antennas, like on each side, like one, right? Is that kind of like
One for incoming and one
One
for
for-
outgoing.
Okay, gotcha. Okay,
One
that's
RX, one
interesting.
TX.
Okay, gotcha. And then basically the one for the client side, so again, that answers my question, is taking the signal from the clients and kind of amplifying that signal going the other direction also. So then you're not running into that asymmetrical connection. Okay, that's pretty cool. Okay.
But by
So-
the way, the 2 units are the exact same design. You just, like Octavio showed, you just flip them the other way.
Yeah.
So how do they know that they need to talk to each other and
They don't.
And okay.
They don't actually talk to each other. What the units are doing is that they're just boosting the existing signal. They
Okay.
don't communicate with one another in any way. In fact, you can actually daisy chain a bunch of them for uplink and a bunch of them for downlink, and then just put them all next to each other or on either side of the link. None of them will be aware of any other focus in the network.
Yeah, and in fact, that is an interesting point because, well, when you are talking about the clients, you need to face it to the access point, not to the other device that is improving the downlink because they don't need to talk to each other. So it means that you can face your downlink surface to the place where you have a dead spot, and well, you can use your uplink device just to increase the power or the connectivity to, well, for some other devices that are able to connect but doesn't have enough power to send all the data or that have a huge amount of retrial packets.
Okay. So another thing that comes to my mind is, scenario when you let's talk in a scenario where there's going to be, I don't know, multi-tenant building, for example, right? I mean, I have, for example, my AP that's on channel 165, for example, or 161, just, any of those channels. And then I have, like, my neighbor is also got like an AP that, is causing interference in 161, 65, and finding you, how does this device know is that why I'm keeping it closer to my AP? Because then it knows that I need to amplify this AP signal. Okay. And you mentioned there's no SSIDs. It's not rebroadcasting SSID. It's simple raw energy, basically. It's okay.
Layer 1.
Yeah, we don't have a radio.
Okay. So, on the compliance and certification side, right? I mean, you've heard of waveguide systems, right? I'm sure. And I ran into that where a long time ago, I was doing a proof of concept, and it worked pretty good. It reduced the retries and all that kind of stuff for the use case that I was using. But we ran into a compliance issue where there was no FCC certification, even though if it was a passive device, and it became a legal issue. And the company said, "Oh, we don't want to, test this." So I mean, I was looking at your website. As far as I know, and I mean, this is all FCC approved and certified. In case, I'm sure that question will come up, right? Like,
yeah, we don't actually need FCC certification. So our device is
Okay.
not the source of the signal, right? It is
Okay.
just repeating it's not a repeater, but it is just repeating an existing signal. So
Okay.
there are two things that I guess we needed to check. One is to make sure that the radiated power doesn't go above the allowed amount. And the
Okay.
second one being that for wherever you need to have dynamic frequency selection, if you're, near an airport or wherever where you're on a channel where you're not supposed to be at the time, that the decision-making power inside the box allows you to switch over to another channel, and neither one of those apply to us. So obviously we don't go
Okay.
over the max limit of ARP, and we don't make the decision on what channel the AP is operating on. So all of those things that depend on the AP to make the decisions, they are still true for the AP. If the AP is thinking that it's okay for them to broadcast on a certain channel, then our device is just gonna amplify that, multiply that. That's the new word we like to use. It's just multiplying that channel over to another area, but it's not, doing any kind of DFS or anything like that.
Okay. Gotcha.
So no FCC required. And
That's
in Canada, by the way, it's ISET, so no ISET either.
yeah. Okay, that's excellent. That's good. It's good to know. I mean, I know that is an important conversation, and that's what I ran into in my past, and so wanted to kind of ask that question. I mean, this is pretty cool. I mean, I'm seeing the use case. I mean, like incorporated office space. I mean, Mark, K-12. I mean, hallways, because some teachers are coming in
Yep.
and out, right? And sometimes you need that coverage if the school's built like a bomb shelter, right? Like, so hallways won't have coverage. Well, instead of putting multiple APs, possibly utilizing these devices to provide that transitionary coverage for the teacher so they can roam properly, right?
Mm-hmm. Yeah, definitely K-12. There's some possible use cases.
Warehousing. I mean,
what are you guys seeing? What places are you guys seeing as you're talking with people? What are you seeing as places where people want to put these?
And Octavio can talk about all the different places he's gone to put these up, but it's mostly been industrial and warehousing use cases.
Okay.
More recently, he's done some offices, a garage, I think. This week he did a hotel.
Yeah.
Yeah, do you want to talk more about those?
Well, the thing that we were doing at the hotel is that we got a lot of other access points that were providing internet for the guest, but because of a result of the multiple access point, we have seen a lot of noise there and a lot of channel interference. So the thing that we were doing there is that that we installed the devices in a corner, and we extended the range, but we did this thing to bend the Wi-Fi, and we were able to still communicate or to connect to that access point. But the interesting thing that we have observed there is that for the same space, the hotel administration was using around 4 access points, and we were able to cover the same space with just one access point. Very common access point. I will not say the brand because we're not allowed to say that. But yeah, the thing is that we only use one access point. It was set on the lowest power transmission in that we were able to do or that we were able to set, but it was just one access point and one of the device, no, two of the devices to bend the signal.
Oh. So using that logic, I mean, I'm thinking warehouse. I mean, I've done a bunch of work in warehousing, and this solves like a big issue for me, right? Like, I mean, in a scenario like that, what's stopping me from taking an access point possibly? Let's say if I have to cover 4 aisles, I'm just going to use an example, right? If I have to cover 4 aisles, I put an access point right there, and I use, I don't know, maybe 4 of these devices and put them near an AP and cover 4 of my aisles. And I can daisy. You mentioned earlier that I can daisy chain them.
Yeah, absolutely. And that's the building an entire network with them is where the name of the company comes from, LATYS. If you look at like a top view of the network. When you build a network like that you were explaining, Ellie, where you have an AP and then a few of these devices around it, and then that just kind of takes the signal out. That's what it is. This is Octavio's showing the hotel heat map that he did this week.
Yeah,
let him talk you
as you
through it.
can see, the access point was here. And if you, this is something like a meeting room. And here is the hallway. You need to, well, there is a hallway, and then you need to turn to go here where the reception is located. So as you can see, the Wi-Fi signal just died here. When you need to turn it, we lost all the connectivity. But when we installed the devices, give me a second to share this.
So while Octavio is pulling the other one up, I just want to make a point about how there's, we're not adding capacity to the network, right? All we're doing is increasing the footprint. So if capacity is, one of your design criterias, then you need more APs just
Of course.
from a capacity perspective.
Yep.
Okay. Yeah. This is, I mean, more like, industrial manufacturing, warehousing, and all that, where stability and connectivity is more important. I mean, those devices are, transmitting and receiving only, like few bits of data, right? So they don't need technically a lot of capacity. Even there's a lot of devices. So I think, yeah, that's super awesome. Look at that.
Yeah, here you can see that we got these elevator shafts over here. So no coverage was there because I was doing the heat map, just walking around all the places that I was allowed to go. You know how that works sometimes. And here is the coverage after we located the devices over here. As you can see, it almost covers all the reception area. So yeah, it increased the range in something like 40%. And the important thing is that we are bending the Wi-Fi, and we are putting the signal wherever we want to, or wherever we need it.
Okay.
Wow.
Yeah, that's
So
that's
so
pretty
you
cool.
just put one unit in that corner. That's it for this?
Two
Just
units
one?
in that
Two
corner.
units.
Yeah, to complete because
Both
as
way,
we
both
mentioned,
directionals.
the device is pretty directional, so we need to put two units that are facing, well, that are increasing the downlink, or that are improving the downlink, because with one unit we are not able to bend it enough. I mean, instead of bending 90 degrees, we'll be able to bend it around 45 or something like that. And well, after we got this bending in the 45 degrees, we need the other one to bend it the other 45 degrees in this daisy chain configuration.
Okay, cool.
Okay.
That's
And
awesome.
obviously, then at the same
Cool to
time,
see.
it's amplifying the client signal too. So yeah, I can understand that. Yeah, you didn't do any iPerf or any testing before and after, but I'm curious about that too. I mean, I'd love to kind of see what it looks like, right? Because obviously on the client side, right? Like, before, if you run an iPerf, there's going to be a huge difference before and after also.
Well, it's raising your SNR, so
Yeah.
it definitely would have better SNR, so you're going to have better throughput.
Yeah, definitely.
Did you do an iPerf test?
No,
For the
for this
hotel? No.
case, no.
Okay. Yeah, I
But
was curious about
he does have results from other ones that he's done that he has iPerf results from, and you can see those, speed tests and packet retries.
Well, hopefully, if you have enough units become available and I get to have your units, I would love to kind of test that. And of course, and as I mentioned, right, like November 12th, we have the YCO event that's happening in the DC. And if I am able to get the units, I would love to kind of like actually grab some data to kind of show it. And I'll totally bring the units so people can actually see them and test it out themselves, right? Like, here you go. We're, like build our own little Wi-Fi network no
And do your
restrictions.
own bending.
Yeah, do your own bending, right? Like in different ways. It's a museum that we're actually doing this event in. So let's see. I'm sure we'll find places where we can, where we can bend some signal in the hallways or something like that.
Yeah, that'd be cool.
How does it work?
Okay, now
with
I kind of want to go to the Waco in DC.
Yeah, we try to pick places that are interesting. I mean, I'm sure, like, North Carolina, it was a botanical gardens. In DC, it's a museum. And I don't know. I'm thinking about a Nashville one. Probably is going to be zoo. It's going to be the Nashville Zoo, possibly. I don't know. Just one of the things that are in my mind.
That's really cool.
But yeah,
That's
the
pretty cool.
Montreal event was pretty cool. I wish I was traveling for work. Otherwise, I was absolutely planning on coming over there. But it looks like that was an interesting event.
Yeah, it was a lot of fun. We had a lot of fun hosting everybody. And then, as startups do afterwards, we had we brought out the beer and the wine, and I think everybody had a good time. But we are going to be in Chicago, I think, on September 10th, and in Atlanta on September 12th. So
Okay.
if you could make either of those, Mark and Ali, either of you, if you could make any of those, it'd be nice to see you in person, and then you get to see the demos live.
Where exactly in
Octavio's doing
Atlanta
the roadshow.
Where exactly are you going to be in Atlanta?
We're going to be at the Kimpton Hotel at both of these locations. So Kimpton Hotel in Chicago and Kimpton Hotel in.
Okay.
Awesome.
Yeah, I may have to cancel or not cancel, research on my travel plans because I'm really interested. In checking out this cool technology. Very excited in seeing it. What about planning for it, right? So obviously it's all great and everything, but all this obviously requires planning. So if I'm working under the big floor plan or something like that, right? I mean, where the units need to be placed, where the APs are going to be, obviously recommended distance and all that kind of stuff, right? All that needs to be planned out, right? You can't just randomly throw these kind of things out there. So talking about tools, right? I mean, Hamina, which is what I use, extensively every time I'm doing my design. Is that something that eventually is going to be in there, or you're working on where we'll be able to, hey, pick your product and place it there?
So when Jerry was here for Wyco, we had a long conversation about how we could add our device into their tool. We've had similar conversations with other planning design tools. It's kind of a little bit more complicated than you might think to add our device into the tool, because you need to actually do both planning for both uplink and downlink, because the devices are unidirectional. So you need to not only do that, but to also factor in the fact that how far you are from whatever source of the signal is going to impact the output signal. So it's not a direct relationship of, I put an AP here, I'm always going to get this type of pattern, versus the lattice focus. If you just place a lattice focus on its own, you're not going to get any kind of radiation pattern. Where you place it as in relation to an AP, or to, if you're designing for uplink on the user side, will make the difference. So it takes a little bit more of like the overall layout than just our device on its own. So we have come to the conclusion that if nobody else sees the business case of adding our device into their tool, then we're going to need to make our own. And we have a rudimentary one that we use ourselves that we've designed so far, that our team uses just to kind of get an idea of a comparison between multiple layouts. So, if I place it here, what does it look versus, half a meter away, you're at 20 degrees like tilted, or that sort of thing. But to make it available for everybody else is a whole other ballgame. So we're actually going down that path right now, trying to figure out whether it makes business sense for some of these existing tools to do it, because it's not going to be technically super challenging for them to add it. It's just, are they willing? Do they see the benefit of doing it?
Yeah, I think as people start using the product and then they will see the need. Obviously, I mean, you see Joel, feature request coming your way soon, right? I'll probably be the first one putting it out there. But yeah, I can absolutely see it, and I'm thinking, I mean, this would be an interesting thing designing it. I'm kind of excited about it, because you got to figure out, the distance and all that, like you mentioned, right? You can't just randomly throw them right there. Oh, let me just put one right there and one right there, and okay, it should be fine, right? Figuring out uplink, downlink, how's it going to impact it. Possibly, whatever vendor tool that's being used can have some AI magic in there, or some kind of intelligence in there that can say, if you're extending the recommended distance that you specify, okay, well, hey, it's gonna, there's some kind of legend that shows how is it going to impact your performance towards the bottom, right, and all that kind of stuff. So you can
Actually, our
design.
tool has that. Our tool
Oh,
has
okay.
that. Yeah, it can give you a recommendation on how many of these devices do you need and where is the best place to put them.
Okay.
Just from it's an AI tool that gives you
Okay.
that, just based on the layout, based on the number of APs you have in the network, based on we have a list of criteria that it takes as an input. So how many APs do you want to use? How many users do you have? How much coverage do you want? What kind of RSSI are you trying to reach for the overall area, that sort of thing. So you give all of those as an input to it, and it gives you a recommendation. Use 6 lattice focuses. This is the kind of orientation we're suggesting, that sort of thing. And then you can kind of move them around and play around with them and see what you can change from what the optimization is giving you from our tool.
Okay. Is that tool if Mark and I wants to access that tool, is it something online available, or is it just internal dev team that uses it?
So it is on our server.
Okay.
We could make it available.
Okay.
That's actually what we're thinking through right now, is that if
Okay.
installing it requires it, and if we're not going to be the ones who are going to be doing all the installation, then we should probably make it available. It just needs to be robust enough for everyone to use it, right? So that's the
Okay.
topic of the day. You can never build hardware without building software. So
Yeah.
we're gonna need to do both. Yeah.
Yeah. One thing I forgot to ask, and I kind of want to, again, probably the last thing. So with multiple spatial streams, MIMO, and all that kind of stuff, right? With the access point, and does this make it kind of go away? Does it become like everything like a single spatial stream kind of thing, or is it still? It's just
We
repeating the
haven't
signal.
seen any kind of impact, because all
Okay.
we're doing is we're repeating the signal, right? So and generally all the antennas from whatever multiple streams are going to be inside the same box on your AP side, so they're going to be in the acceptance cone of our
So you're
device.
repeating all that. Okay.
So we're just repeating all of that. Yeah.
Okay, gotcha. I wanted to make sure, because with waveguide, for example, I was running into one of the things was, yes, it was improving the signal and everything, but it was making the whole system just a single spatial stream, right? But in your case, that's not happening. It's basically.
That's not what we've noticed. Yeah.
Okay, gotcha.
But you can challenge the device once you have a pair.
Yeah,
Once you have a pair.
Yeah, looking forward to it. I'm very excited about it. It's a very cool technology. It's everyone I'm sure you've talked to, and I'm sure you're testing it and all that kind of stuff. So it's really cool to see something like this right out there. And tons of use cases.
I was able to find some data regarding the test that we have performed for some for one customer. Let me show it to you, because I was just checking that we are not including any information of the customer, but here you can see the thing that we mentioned before. We have seen the increase on the dBm, or in the RSSI power, and here the numbers for the throughput.
Wow. Almost
That,
doubled.
as you can see,
That's almost
here
double.
yes, sir. Well, we know that once that we reach the minimum signal level, everything else it's on charge. Well, it's on the protocol side, but
Yeah.
we are coming from a scenario where we barely able to connect to a pretty decent amount of data. And as you mentioned before, the thing that we were thinking of, it's scenarios where we don't have any kind of coverage, so you are not able to connect. So it comes from infinite to a number, right?
Yeah. That's amazing. That's pretty
That's
awesome.
awesome.
Yeah. And this is currently just 5 gig, correct? Which
Yes.
frequencies are you supporting?
5.2 to 5.6. Is that right, Octavio?
Yes.
Oh, you're doing 6 also.
5.2
5.6.
gigahertz to 5.6 gigahertz.
Oh, okay.
So it's just in the 5 gigahertz range. The
Oh,
next
okay.
thing we're working on is a version that can cover 5 gigahertz and 6 gigahertz. So we can do, you know, up to 7.1, basically cover all of 6E as well, or the 6 gigahertz.
Any plans on supporting CBRS frequencies?
So
Mark, I'm
that's like
surprised you didn't ask that
3.4.
question.
I know the answer, but
Not yet. Yeah, not yet, but we will. So we have on our roadmap, we have a plan to cover as many of the useful frequencies as possible to allow for, because these are protocol agnostic, vendor agnostic boxes, right? So you could really see all the benefit of having them for a bunch of different frequencies, so you can use them as you need.
Absolutely. Yeah, absolutely. I mean, I definitely see a huge use case in the CBRS side of the things too. I mean, especially some of the recent deployments I've done and all that. I'm like, yeah, it'd be cool if I can use it. Of course, on the Wi-Fi side as well. So that's awesome. Well, I mean, yeah, we're pretty much ending this. Thank you so much for hopping on the call with us and giving us a detail about your product. I am excited about getting, a couple of these in my hand and testing them out, and keep an eye out. Like once I have them in my hand, we'll definitely, if I cannot show them by the YCO event in DC, I mean, I'm sure Mark and I will have another, probably an episode. I mean, we were talking about doing it at the Utah Salt Flats, right? I don't know.
Yeah.
I don't know if that's still a possibility or not. Let's see how far we can extend this, right?
Yeah.
Push it to the limits.
I don't know. I think it'd be really cool if we could test them there.
Yeah, absolutely. Well, thank you so much again.
Awesome.
Yeah, have a wonderful day.
Thank you very much for
and-
having us.
Yeah,
Thank
absolutely.
you, guys.
All right,
guys.
take care. Yeah.